Hi, and welcome to our next video on mountain wave turbulence. We looked at mountain waves, the different types of mountain waves and how you can identify them. Now we're going to get into other types of wave phenomena. And specifically, the first thing we're going to talk about is strong downsloping winds. So strong downsloping winds result when the flow at higher elevations comes down and follows the terrain in the lee of the Rockies or the lee of the mountains, and as it descends it accelerates. So you have a conversion from potential energy, meaning high altitude, perhaps low velocity, to kinetic energy, where you have low potential energy and high wind velocities. So in other words, the winds increase as they descend along the mountain slope. And typically you'll find the winds twice the strength that they were at the top of the mountain. So if the winds blowing over the mountain crest were about 50 knots, you may see winds in excess of 100 knots. This is very common in the lee of the Rockies, lee of the Cascades, under certain conditions. And it can cause substantial damage. These pictures are from Boulder, Colorado, after a strong wind event, but winds can exceed 100 miles an hour or 100 knots. And the kind of turbulence that you get with this is mechanical turbulence. Of course, the wind blowing over the ground produces very, very strong turbulence close to the ground. Typically, when you have a strong downsloping wind event, no one's flying aircraft at the airport. As a matter of fact, the airplanes that are tied down can become loose and flip over. You see this quite frequently at airports close to the Rocky Mountains, such as the Boulder, Colorado airport, or Longmont or Jeffco. Strong downsloping winds typically occur under three different types of flow patterns, either with block flow or with vertically propagating gravity waves, or even when the flow follows the terrain. The next phenomena we're going to talk about is hydraulic jump. And hydraulic jump is a steady disturbance that happens downwind or in the lee of mountains. Typically occurs when you have strong downsloping winds. So in other words, as the wind flows over the mountain, it follows the terrain, it accelerates as it does that, so the wind velocities are very high at low altitudes. And then suddenly they jump. In other words, they have so much energy that they become unstable and they climb higher in the atmosphere. And as they do that, they convert their kinetic energy into potential energy. It's hard to describe. This is something that you see in fluid dynamics, but perhaps maybe the best way to explain it is either looking at a waterfall, or maybe even better is if you have a faucet that is pouring water on a plate, and as the water moves away from the stream of water, it is moving very fast until it gets to a point where it becomes turbulent and becomes slower, and there you find a ridge that's a little bit higher than the surrounding water. So this typically happens under block flow conditions and also with vertically propagating waves, but more so you'll see it with the vertically propagating waves quite frequently. So this goes hand in hand with strong downsloping winds. When you have strong downsloping winds, you also have a hydraulic jump, and that seems to happen more frequently with vertically propagating waves. So usually the hydraulic jump occurs very close to the mountains, not very far downwind, and it's on the lee of the mountains, in other words on the downwind side, and it usually indicates the farthest extent of the strong downsloping winds. In other words, the strong downsloping wind speeds will stop where you see the hydraulic jump. Beyond that, farther downwind of the mountains, the winds will be rather light. But from the mountain crest down to the hydraulic jump, that's where you'll find the strong downsloping winds. So needless to say, with the strong downsloping winds and the hydraulic jump, that is where you have your worst turbulence. You have a very strong turbulent zone. And right at that interface in between the rotor and the hydraulic jump is typically where the turbulence is the worst. We'll talk about rotors in the next video. So stick around and we'll talk about rotors and also Kelvin Helmholtz waves.